Hello class. Today we're going to talk about simplifying radicals. But first, let's review what we talked about yesterday. So what I'd like for you to do is prime factor each one of these monomials. So pause the video and prime factor them like we did on our assignment the other day. Okay, so let's see how you did. So the first thing we have to do is break this 72 down. Now we know that the best way to do this is to try to pick two numbers that are close together. You could use 36 and 2, but that's going to make for a longer factor tree. The closer these first two factors are, the shorter your tree is, typically. So for 72, we know that's going to be 9 times 8. Okay, now we ask ourselves, will the 9 and the 8 break down? And yes, it will. So the 9 breaks into 3 times 3. Now the 8, like I told you the other day, it's the only number that I don't break it down just into two numbers. I break it down into 3 because I'm lazy. So I break it down into 2 times 2 times 2. Okay, so if we were to write that in numeric order, then you're going to write it as 2 times 2 times 2 times 3 times 3. And then we'll break our letters down. So t to the third power means t times t times t. And that would be the prime factorization of 72t to the third power. Now, what if that number was negative? Do you remember what we do? Okay, if it's a negative number, we're going to factor out that negative first. So it's going to be negative 1. To factor out means to pull out, times 20m n to the fifth. And now we have a number that we can break down, because you can only prime factor positive numbers. Okay, so we break down the 20, and the 20 breaks into 5 times 4. Okay, so then the 4 would continue to break down into 2 times 2, and the 5 slides. And then we bring this negative 1 all the way down to the front. So to write this one, it would be negative 1 times 2 times 2 times 5 times m times n, 5 times. Okay, so that would be prime factoring polynomials or monomials. Sorry about that. Now what we're going to be working on today is simplifying radicals. So my first question then is, what does the square root of 25 really mean? Well, we know that the square root of 25 means what number can I multiply by itself to get 25. So if you were to type in on your calculator the square root of 25, second square root 25, enter, you would get 5, because the question that it's asking is what number can I multiply by itself to get 25. So how does prime factorization and square roots, radicals, go together? Well, let me explain. So what you're going to do is you're going to take this 25 and you're going to prime factor it into 5 times 5. And what we're going to do is we're going to take that 5 times 5 and we're going to place it underneath the radical. Now, what we're going to do with this is we've got to learn how to simplify radicals. And what that means is when we look at this radical, there's a little spot for a number right there. Okay, now if there's not a number there, there's actually a 2 there. Okay, so that what that means is that I'm looking for 2 of a kinds. And if underneath the radical there's a 2 of a kind, that 2 of a kind can jump out of the radical and become a single number on the outside. So the square root of 25 is 5. So let's do another one, because you may not quite get it just yet, and that's okay. Okay, but you'll notice, just plain simple answer. Same thing we got on our calculator. So what if I gave you the square root of 125? What does that break down into? Well, 125 breaks down into 25 times 5. And this 25 breaks down into 5 times 5, and this 5 slides along for the ride. So the square root of 125 is really 5 times 5 times 5. Well, just like in that previous problem, there's not a number right there.
Ms. Davis, you need it at the front of the building.
So just like in that previous problem, there's not a number right here. So there's a 2 there, which means I'm looking for a 2 of a kind. Okay, so when we look at this problem, do we have any 2 of a kinds underneath the radical? Yes, we do. We've got a 2 of a kind right there. So that 2 of a kind can jump out and become a single 5 on the outside. So what do I do with that 5 that's left? Well, what we do is we just leave the 5 underneath the radical. So the simplified answer of what's the square root of 125 is 5 times the square root of 5. Now, to check to see if that really is correct, we do second x squared to get our square root, 125, enter, and we get an ugly decimal answer. So if we do that with this other one, 5 square root 5, we should get the same exact answer. And that tells us that that is the simplified form of the square root of 125. So in essence, to answer a square root problem, we're going to do a series of things. So I want you to write these steps down, and then we're going to do a few problems as examples. First step, you have to prime factor the number underneath the radical. So pause the video if you need to write these down, because I need you to write these down. It says steps to simplify square roots. First, prime factor the number under the radical. Second, pull out your pairs from underneath the radical. So when you break it down, that square root is going to be looking for 2 of a kinds. So what we're going to do is we're going to pull out any pairs that we may see. Now you may have more than one pair, and that's okay. So if I pull out more than one pair, then you're going to put them together through multiplication on the outside. We'll see an example of that shortly. So next, multiply the numbers outside of the radical if needed, if there's more than one. And then last but not least, we're going to multiply the numbers that are still left underneath the radical and put those back together. Okay, so in the square root, only pairs can jump out. So let's take a look at this next number here, the square root of 54. So the first thing that we're going to do is break that 54 down. Now we know 54 breaks into 9 times 6. So this 9 is going to continue to break down into 3 times 3. The 6 is going to break down into 3 times 2. So underneath my radical, what I really have is 2 times 3 times 3 times 3. Okay, so that is the square root of 54. That's what it breaks down into. Now again, if you'll notice right here, I don't have any numbers there, so that means there's a 2. So I'm looking for 2 of a kinds. It's important to understand that idea. So do I have any 2 of a kinds underneath the radical? I do have a pair of 3s. They can jump out and become a single 3 on the outside. So 2 on the inside become only 1 on the outside. Now, do I have anything else that can jump out? No, I don't. So what we do is we take the 2 numbers that are still underneath and you just put them back together through multiplication. 2 times 3 is 6. So if we were to type in the square root of 54, we get 7.3 blah, 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 blah. And if we type in 3 times the square root of 6, we should get the same exact answer. And we do. So that's how we simplify a radical, simplify a square root by hand to get an exact answer. Because 3 times the square root of 6, which is how we say that, is an exact answer. The answer that you see over on the calculator is an approximate answer because it has been rounded. Okay, so what if I gave you 54x squared? Oh my goodness. Well, we just did 54. We know 54 is 2 times 3 times 3 times 3. So that means we would have the square root of 2 times 3 times 3 times 3. But in this one, we also have an x and an x. Okay, and it's okay to have that. Okay, so again, we're looking for, since there's nothing there, there's a 2. We're looking for 2 of a kinds. Do I have any 2 of a kinds? I've got a pair of 3s, but this time I also have a pair of what? I have a pair of x's. So that means on the outside, I'm going to have a 3, and I'm going to have an x. We put that together through multiplication, which gives us 3x. And then we take whatever's left underneath, and we put it back together through multiplication. Now this one, you can't check the letters, okay? But you can check the numbers. And we already know that the square root of 54 and 3 times the square root of 6 are the same. But I also wanted to show you what happens when you do those letters, okay? So let's try one more. Okay, so pause the video and answer this question on your own. Let's see how you do. Okay, so let's see how you did. Okay, well, first off, we're going to break down 120. Well, I know that since it's got a 0 on the end, I know it's just 12 times 10. Okay, so this 12 will then break down into 4 times 3, or you could have used 6 times 2. This 4 will continue to break down into 2 times 2. This 3 is going to slide. This 10 will break down into 5 times 2, and then both the 5 and the 2 just slide right on down. Okay, so underneath my radical then, I'm going to have 2 times 2 times 2 times 3 times 5. And now we have our letters. X, 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 Y, Y. Okay, so that's what we've got. So now we begin looking for pairs. Do I have any pairs that I can pull out? Well, I've got a pair of 2s. I've got one pair of X's. I've got another pair of X's. And I have a pair of Y's. So that means I've got a 2, I have an X and an X and a Y on the outside. So what would that give us? Well, the 2 is self-explanatory. The XX, how would we write that using exponents? X squared, and then the Y comes along for the ride. Okay, and then we take whatever's left underneath, which in this case is the 2, the 3, and the 5, and an X. We're going to put those back together through multiplication. So we'll do 2 times 3 times 5, and you end up with 30. So 30, and then we've got one X left, X. So our answer is 2x squared y times the square root of 30x. Okay, now, could you check this? Well, like I said, you can't check the letters, but you can check the square root of 120. And is that the same thing as 2 times the square root of 30? Well, let's see. Okay, x squared, okay, square root of 120, enter. Then 2, square root 30, enter. And sure enough, it is. So this is our final answer. Okay, so that's how we do square roots. Now, what if we didn't have square roots? What if we did have a number here in the corner? What do you think that's going to say? Okay, well, if you have that, when there was a 2 up here, when there was a 2, when we didn't see it, it was a 2, we looked for 2 of a kinds. So what do you think we're going to do in this one? We're going to look for 3 of a kinds. So it's going to take 3 to jump out as opposed to 2. Okay, so let's take a look at that. Okay, so the first thing we still do is we still break the 27 down. 27 is going to break into 9 times 3, which the 9 is going to then break down into 3 times 3, and this 3 slides. So we've got the cube root of 3 times 3 times 3. Now, in this particular one, what are we looking for? We're looking for, according to this, 3 of a kinds. So do I have a 3 of a kind that can jump out? Yes, I do. And I end up with just plain old 3. So the cube root of 27, which is how we say that, the cube root is 3. So how do we do this? How do we check this one on the calculator? Well, in order to check this one, what you're going to have to do is go into the math menu. Okay? So in this math menu, you'll notice on number 4, we have a cube root. Well, that's the one that we're going to use on this one. So you would type in 4, math 4, so that gives you that cube root, 27, enter, and you'll notice it does say that it's 3. Now, we're going to do the same thing for this other one, okay? But what I'm going to do is I'm going to let you pause the video and see if you can answer this one by yourself before we actually do it together. So pause the video and answer this question. Okay, so let's see how you did. Well, 81, when we break it down, is going to break into 9 times 9, which will then break into 3 times 3 times 3 times 3. So that means that this one is the cube root of 3 times 3 times 3 times 3, and then x, x, x. So that's what I need to find the cube root of. So what we're going to do is, because of the 3, we're looking for 3 of a kinds. So do I have a 3 of a kind? Yes, I do. There's a 3 that's going to jump out, and I have an x that'll jump out. Okay, then what am I going to leave underneath? Okay, I'm going to leave underneath it just a 3. Now, let me ask you something. Is there anything wrong with my answer? Yes, there is. If it doesn't have a number there, what am I looking at? Square roots. But what do we have here? What is this problem? This problem is a cube root. So in your final answer, if you have anything left underneath the radical, you have to make sure you put that little 3 in the corner because that tells us what we were looking for. Okay, now to check this, again, you can't check it with the numbers, with the letters, but you can check it with the numbers. So we go math, 4, 81, enter. And we end up with 4.326, blah, 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 blah. Now to check the other one, we're going to do 3, math, 4, and see it gives you the same thing. 3, enter, and notice we have the same decimal answer. So that's how we do cube roots. Now what do you think we would do different if we have a 4 in the corner? Now it's going to take what? It's going to take a 4 of a kind to jump out. So pause the video and let's see if you can answer these 2 questions on your own. Okay, so let's see how you did. Well, I know that 625 is going to break into 25 times 25 because I know 25 times 25 gives me 625. So then my 25 will break into 5 times 5 and 5 times 5. So that means really I've got the 4th root of 5 times 5 times 5 times 5. So because of this little 4, that means we're looking for a 4 of a kind. So it takes 4 to jump out of the radical. And I've got 4 5s, so they jump out, and my answer is just 5. So how do we check this one? Well, if you noticed under the math, if you were to look at 5, it's got the nth radical. Okay, that's what we're going to be looking for. But here's how you use that one. What you're going to do is you're going to type what goes into that n spot first. We're going to put a 5, and then you're going to do math 5. And the way that registers it, oh, I guess it didn't do it that way. Well, let's do it again. So on your calculator, that's the way we used to do it on the calculators. So let's do math 5. And now it actually, I guess, puts a little spot right there, and we're just able to type it in. So we type in a 4, then hit the right arrow key, and now it's allowing you to type in the stuff on the inside. And we want 625, enter, and you'll notice we get a 5 there. So now let's look at this next one, this last one here. Okay, we got 96. Well, I don't know off the top of my head what will go into 96, but I know because this is a 6, I can divide it by 2. Or because I've got a 9 and a 6, I could divide it by 3 as well. So I'm going to do 96 divided by 3. I end up with 32. So that's going to give me 32 times 3. And now this 32, well, I know that. That's going to be 8 times 4, and then the 3 slides. This 8 is going to get a trie-break into a 2 times 2 times 2. The 4 is going to get a 2 and a 2, and then the 3 is going to slide. Okay, so now I've got the 4th root of 2 times 2 times 2 times 2 times 2 times 3 times m. Now I'm looking for 4 of a kinds. Do I have any? I've got a group of 2s. And I've got a group of m's. So we put those together with multiplication. And then we leave underneath the radical. We've got a 2 and a 3, which we put back together for a 6, and an m. And then there's my final answer. So let's see if that actually works. So let's do math 5. We'll type in a 4, right arrow key, 96, enter. And then we do the same thing again. But this time we're going to stick a 2 in front. So 2, math, 5, 4, right arrow, 6, enter, and we get the same answer. So in order to simplify radicals by hand, this little number in the corner is very important. It's going to tell us what we're looking for. If there's no number, then that means it's a square root. We're looking for 2 of a kinds. If it's a 3, that means we're going to be looking for 3 of a kinds. If it's a 4, we're going to be looking for 4 of a kinds. If it were a 5, we're going to look for 5 of a kinds. Okay, so just to review, the first thing that we do is we prime factor the number under the radical. Okay, so we break everything down. The second thing, you pull out your pairs. Or if it's a 3, you pull out your 3 of a kinds. Or if it's a 4, you pull out your 4 of a kinds from underneath the radical. You take the numbers on the outside, whatever's out there, you put them together through multiplication. You take the numbers on the inside, the ones that are left, and you put those back together through multiplication. Then you check your answers just to make sure that it's correct. So that's how we simplify radicals. It's really not as bad as you might have thought it had been, but it's really pretty simple if you understand the idea of prime factorization. Makes it very easy. It's one of the main reasons why you learned how to do it back in 4th and 5th grade. So what you're going to do is you're going to do a little assignment for me. Now you'll notice on this assignment that it doesn't have any letters, okay? It's just plain old square roots and cube roots and 4th roots and, oh yeah, and the last one is a 5th root, okay? So let's look at one together and then we'll end this video. So the first one is the square root of 12. So we go through our steps. First step is break the number down, okay? So this 12 is going to break down into 4 times 3. And then 2 times 2 times the 3. So really this is going to be the square root of 2 times 2 times 3. So since it's a square root, we're looking for 2 of a kinds. So that means we've got a pair of 2's that'll come out and nothing else. So whatever's left on the inside, we just leave it there. We put it back together through multiplication and we leave it. And then we come over and we check our answer. So second, x squared 12, enter. 2 second x squared 3, enter. And we find out that they're the same thing, so there's my answer. So that's what we're going to be doing today, simplifying radicals. So this lesson, we're going to do the assignment tomorrow in class. So this is the video to learn how to do it so that tomorrow we'll be prepared to solve and simplify radicals. So until next time, I'll talk to you later.